Weird. Okay, so everybody, can y'all hear me? Yay, okay. All y'all missed was the joke. I'm sorry. You missed the joke of the day. All right, so I have a few announcements before we start. And let me put chat up on this computer. Okay, I'm gonna close that. Okay. While y'all are checking in on attendance, I have a few things to talk to you about. All right, so if you need homework help, I'm happy to help. I want to help. But I can't always help the night that the homework is due. So if you need help, you need to try to talk to me as soon as you can. There are two ways that are really, I guess the best ways for me to help you on homework. One of them is to set up a Zoom. Do y'all know how to set up a Zoom with me? It's really easy. You go to the Moodle page. You come down and see my contact info, my phone number, my email. The very next link right here says Calendly. I can't pronounce it. But anyway, it's my calendar. And you see these blue circled days? These are the days that I have open appointments. So if you click on any of the days, you're going to see the available appointments. If you really need to talk to me and I don't have something open, send me an email and maybe we can work something out, but it'll take a little bit of time. So try to plan ahead, try to get ahead, so that you have time. And so if you click on one of these, click confirm, you'll put your name, you'll put your email. Now, one thing that's kind of cool that I haven't said is that let's say you and your friend have the same question, or y'all want help with the same topic. You can add a guest so that there can be 3 of y'all or 10 of y'all who have a question and we can Zoom and figure it out together. Don't feel like each individual person, if y'all have the same question, we can all get on a Zoom together. Okay? Does that make sense? And then when you do book it, give me your phone number in case something happens and I need to get in touch and say, I don't know, who knows, but can we wait 5 minutes or even whatever it is. Sometimes we have technology issues, but it's just a way for me to get in touch with you. You tell me what section and you tell me what you need help with. So don't just say the homework. Say, I'm having trouble typing in the structures for items like 17 and 18 on homework 5. Right? Give me the most information you can here so I can be as ready to go to help you as possible. What if you don't want to Zoom? What could you do? A bunch of people have done this so far. You can email me. But if you email me and say, Dr. B, I'm having trouble with number 18. How much can I help you? Not so much, right? So I'm asking you to send me 3 things if you need help with a particular problem. Especially if it's a homework problem. Take a screenshot of the problem, right? The question. And then, so Jason, you're going to pick 5T. It doesn't matter. You're going to pick 5T because you're in 5T. So take a picture, take a screenshot of the question, because sometimes it's not that you're doing it wrong, it's that you didn't read the question all the way. And so I can circle it, I can write your notes, stuff like that. Then, especially for those reactions where you have to draw stuff, handwrite your answer. Show me your work. Take a picture of it. Because I can actually write on that. And then take a picture of, I tried this. This is what I submitted, and it came back and it told me it was wrong. Take a picture of what you submitted. That way, I know if you're translating from your written work to the computer program correctly. Like maybe you did all the work right, but then when you go to put it in the program, you're missing something, right? And vice versa, you might be putting something in, you might be putting in exactly what you think you're putting in, but your answer, your written work answer is incorrect, right? So the more information you give me, the better I can help you. Questions on that? And if everybody's having trouble with a problem, I'll do kind of a tutorial thing where I video how to do it. Because y'all all saw that for this last chapter, right? Yes? If you are not getting announcements from the forums, you need to change your settings so that you get those announcements. Or the emails about announcements. I don't know how to say that exactly, but you know what I mean. And that way, if I know if a bunch of people are struggling, I'll put one of those together. Whatever I can do to help y'all, okay? All right. Thing number 2, I changed our schedule. So I was making all of these videos for chapter 6. Y'all know how many sections are in chapter 6? Did I look ahead? 7. There are 7 chapters, 7 sections in chapter 6. Okay, so here is our calendar, right? And y'all know how to get here, right? Okay, so we are here. We're Thursday. We're on chapter 6, part 1 lectures 1, 2, and 3. The original plan was for Tuesday for us to do 4, 5, 6, and 7. It was too much. It was too long. So what I did was I'm moving 2 of those sections to Thursday. So that means our homework gets pushed back. Our homework gets pushed back to being due on Monday for chapter 6. And then we'll start chapter 7 the following Tuesday. The following Thursday was supposed to be an exam, but that'll be our chapter 7. Then chapter 7 homework is due on Monday, and then we'll have an exam on Tuesday. So this is Tuesday, October 20th, and then drop day is Wednesday, October 21st. So you'll have your 3rd exam grade before drop day. Good? Questions on that? Okay. All right. And what else am I have this like list of things I wanted to talk to y'all about. Oh, in the chapter 6 homework, y'all know all the homeworks have had like 20 questions so far, right? 20 problems. I put a couple of extra problems in chapter 6, but don't freak out because I made them extra credit. So you can, I know that people have been struggling and that kind of stuff with the drawing programs and all that kind of stuff. So I want you to get those right. I want you to figure that out. But if something happens and you can't, there are some extra problems that you can do to make up those points. And if you get them all, you get bonus points. Okay? So when you look, you'll see that some of them are worth, like each question is worth 1 point, and some of them are, they'll say extra credit, extra points, they'll say something. I don't remember exactly what it says, but it'll tell you. Okay? All right. Okay. So I'm going to start with some clicker questions, but I'm going to use our clicker questions as a review for what we did in the last class. So I'm trying to pick up your iClicker scores, trying to do you a favor here. So that if we have our iClicker questions, like we're starting chapter 6 today, so if our iClicker questions are on the end of chapter 5 today, you've done the homework for it, you've seen all the lectures for it, right? You should be more accurate in your answers if we do it this way. So let's try it out and see what we get. All right. I think this is what we ended on last, the activation energy. I think this was our last one. Okay. So, which of these changes are going to increase the rate of a reaction? So let me start a new one. Which of the following changes will increase the rate of a reaction? Can you get a minute? 30. 10 seconds. Okay. Probably more people who are here, but okay. So let's look at A. Decreasing the concentration of the reactants. Tell me, is that going to increase, decrease, or no change? That's going to decrease. Whoa. Decrease. And the easy way to think about this is to think about those cars on the road, right? An analogy for decreasing the concentration of a reactant is decreasing the number of cars on the road. If you have fewer cars on the road, you're going to have fewer collisions, right? Fewer crashes. Well, what makes a chemical reaction go? A collision. It has to be a productive collision. So if we have fewer cars on the road, what's going to happen to that reaction? The rate is going to decrease. All right, how about B, lowering the temperature? Are we going to increase, decrease, or no change on the rate? This is another decrease, right? Think about temperature. Temperature is really speed of particles. So if every car on the road slows down, are you going to have more accidents or less? Less accidents, less collisions. So your rate is going to drop, right? So always think about progressing as collisions and use that analogy of the car. All right, adding a catalyst. Is that going to change our rate of our reaction? Yes, how's it going to change it? It is going to increase it. This one's going to increase it, right? How does it increase it? So a catalyst will decrease the activation energy. Decrease the activation energy. Okay. All right. And then D, both A and B can't be that, and E, all of these can't be that. So we need answer choice C. So what did y'all say? Most of y'all said answer choice C. And somebody in the chat says, do the iClicker questions that we get wrong count against us? If you get a 70% or above, that means you're going to get an A for the iClicker points, right? And at the end of the semester, you get 150 iClicker points. How many points is an exam? 100. How many points are you getting for iClicker? 150. It's supposed to help you out. It is supposed to help you out, okay? And then if you're below 70%, then it's on a 10-point grading scale after that, right? So if you get a 60 to a 70%, that's a B, right? And so on and so on and so on. So do your best on them, but if you miss one, it's okay. All right. So I graded that one. All right. And we answered that one. All right. Select the reverse reaction for this equilibrium. Notice that this reaction has a double-sided arrow. So tell me which reaction listed below is the reverse of the one that's up above. Maybe the Jeopardy sound. Sound good. Okay, 10 seconds. Okay. So 40, ooh, I'll get those answers in. All right, so when we write any old equation, what does it look like? Looks like reactants going to products. So if I wanted to write the reverse of this reaction, what would I write? What's the reverse? I would take my products and I would go to my reactants. So here's my product. I want to start my reaction that way because that's what these double-sided arrows mean. That this top arrow is going in the forward direction and the bottom arrow is going in the reverse direction. So what is that reverse? Well, I have to start with this. So how many equations start with that? Only C and D start with that, but look at D. D has something else as a reactant. Do you have anything else that you would be starting with if we took this reaction and went in reverse? No. So it can't be that one. Well, that's true. So we have what we start with here, and then we're going to make these as products. And that's the same thing as these. So it's just that you have to understand what equilibrium is. Equilibrium is the exact same reaction, one going in the forward direction, and the other one going in exactly the same opposite direction. That's equilibrium. Are we ready to answer a few more questions on equilibrium then? Let's see, what did y'all say? Most people said C. All right, at equilibrium, tell me about the rate of the reactions, of those forward and reverse reactions. Tell me about the rate. And Jason, that is correct. When you're writing the reverse reaction, you don't have to use the double arrows, just because you're not asked if it's a reversible reaction. You're just asked to write the reaction going in the reverse direction. I wasn't watching the time. Y'all click in. Give me 5 seconds. Okay, so before I answer this question, I want to ask you about an analogy. Do you remember the analogy from the book that I kind of talked about? About basketball, and there were players on the court, and there were players on the bench. Do you remember this? A little bit? So on a basketball team, how many players can you have on the court? 5 players on the court, right? How many players can you have on the bench? As many as you want, right? So let's say 20, just for fun. We got 20. Now, in order to play the game of basketball, if somebody comes off the court, if somebody leaves the court, if one person leaves the court, only one, what else has to happen? one person gets off the court and goes sits on the bench, what's going to happen at the same time? Somebody's going to go from the bench to the court, right? So this is an equilibrium. There's an equilibrium between the court and the bench. So what is the bench analogous to? Reactants. And what's the court analogous to? Products, right? Okay, so now let's kind of answer our questions. The rate of the forward reaction is faster than the rate of the reverse reaction. That's like saying that the people going from the bench to the court, we have more going from the bench to the court than we do from the court to the bench. Then I'd end up with like 20 players on the court, and that's not fair, right? So that's not going to happen. The rate of the forward reaction is slower than the rate of the reverse reaction. Then we'd end up with what? Nobody on the court. That can't happen. The rate of the forward and reverse reactions are equal. That is just what you told me happens. Anytime somebody leaves the court to go sit on the bench, somebody leaves the bench to go get on the court, right? So that's the equilibrium. So then, what would happen if the rate of the forward and reverse reactions are 0? You wouldn't have a reaction. Nothing would be happening, right? If the rate is 0, nothing would be happening. So you should have picked C. Let's see what you picked. You picked C. Yay. Awesome. Now, what about the concentration of the products and the reactants? What happens to those at equilibrium? Okay, 5 seconds. All right, so remember our little analogy, right? With our players on the court and players on the bench. A, the product concentrations are greater than the reactant concentrations. Is that true? Not always, right? When I had my little, right, going both ways, I had 20 on the bench and I had 5 on the court, right? But could be a different kind of game, right? Where I had only a few people on the bench and a bunch of people on the court. Same thing, right? Your rates would be equal, but do you necessarily have to start with a lot of product versus a lot of reactant? No. How about B, the concentrations of the reactants and the products are constant. Can you ever change the number of players on the court? No, you're always going to have how many people on the court? 5. If 5 people leave the court and go sit on the bench, what's going to happen? 5 are going to get up from the bench and go get on that court, right? So what's your concentration of players on the court? 5 people per court, right? Always. So the concentrations of the reactants and products are constant if you are at equilibrium. That is true. That is absolutely true. The reactant concentrations equal the product concentrations. How about that? Do you have to have the same number of people on the bench on the court? No. The reactant concentration is 0. No. Right? Okay, so what do we say? Good. Good. So make sure that you know the difference between what happens at equilibrium between the reaction rates and the concentration of the products and the reactants. Two different things. So at equilibrium, the rates will be equal, right? But the concentrations are going to remain constant. They're not going to be equal, but they're going to be constant. So try and study that if that one kind of got you. Okay, and that's it for my clicker questions. Okay, can close that one. Any questions on those? I should have said that before I close it. Questions? All right, so now we're going to talk about sugars. Are we ready? Classify the following carbohydrates as monosaccharide, disaccharide, oligosaccharide, or polysaccharide. What does saccharide mean? It means a sugar. It's a sugar. So what does mono mean? One sugar. How about di? What does disaccharide mean? Two sugars. Okay, now here's where it gets a little bit tricky. What's the difference between oligosaccharide or polysaccharide? What is oligo? 3 to 9 sugars. And then our poly is greater than or equal to 10, right? So 10 or greater. All right, so raffinose, which is a soluble fiber containing 3 carbohydrate units. What are we, mono, di, oligo, or poly? 3 is telling me oligo. That's an oligosaccharide. Starch, a storage carbohydrate of plants that contains thousands of glucose units. A glucose unit is 1 sugar. 1 sugar unit. So what should we classify it as if we have thousands? Poly. Okay. Fructose, a simple sugar found in fruit with the formula C6H12O6. We only have 6 carbons. What is a sugar going to end up looking like? Do you remember this? I drew this at the beginning of the lecture. Yeah? And then usually you have a carbon coming up here. CH2OH, you got stuff, right? How many carbons are in this? 1, 2, 3, 4, 5, 6. So if you have 6 carbons, how many sugars do you have? 1. So that is a mono. Does that make sense? So if you have a disaccharide, then you have a linkage between one ring and another ring, right? And there's your other ring. So that you have 2 sugar units. This is a disaccharide. And then they keep linking together to make bigger and bigger and bigger stuff. All right, identify the following containing soluble or insoluble fiber. So what is something that is soluble? You mix it with water and it will dissolve. And insoluble, you mix it with water and what is it? You add water and it remains a solid. Whoa. Okay, so when we ask about this stuff, right, oatmeal, brown rice, celery, if I just stuck those things in water, would any of them dissolve? No, they're not going to dissolve. But I'm asking you specifically about the fiber inside of those food substances. So it's not the only thing that's in them. So you just got to kind of be careful about that. So this is one of those things you're just going to have to study the notes on. Okay, oatmeal. Why do you have, wait, Ashley said, why do you have one sugar? Why do you only have, for which one, Ashley? 6.2 for C? Oh, because one, C6 is a monosaccharide. This is a disaccharide, but if I erase one of these sugar units, this is C6H12, and so that is a monosaccharide. Yep. Yep. They go by sixes or by fives. Yep. Mm-hmm. Did that answer? You can look at the formula and identify them because they have a common formula, kind of like we did with the alkenes and alkanes. Remember that? You have a similar sort of formula with your sugars. That's exactly right. Okay, so oatmeal, soluble or insoluble? Soluble. But it kind of doesn't quite make sense because you put hot water on your oatmeal and it doesn't really dissolve, but the fiber inside of it will dissolve once it goes through your digestive system. Okay, brown rice, soluble or insoluble? Insoluble. And then celery, soluble or insoluble? Insoluble. And celery wasn't listed explicitly in the textbook. What did it say in the textbook? It said stalks, so it said vegetable stalks. And that's what celery is, the stalk of a vegetable. Okay. All right, now we're going to talk about our functional groups. So remember my little trick. When you're reading these problems, the first thing that you want to do is you want to read the instructions and write yourself a little note about what you're supposed to be looking for. And you remember when I told you to memorize those functional groups? Y'all remember that? It's going to pay off all the studying that you did and memorizing those structures from now until basically the end of the year, okay? You need to know those functional groups. You need to be able to recognize them. You need to be able to draw them, okay? So if you didn't put the time into studying those functional groups, it's not too late. Put the time in now. And if you have been studying, just kind of keep that up, right? Make sure you keep up knowing your functional groups. Okay, so classify each of the following alcohols. What does an alcohol look like? So you have the rest of the molecule and it's bound to OH. That's an alcohol. Now, tell me about a primary, secondary, or tertiary alcohol. If I have an alcohol, it's bound to a carbon, right? Now, what's attached to that carbon is going to tell me if it's a primary, secondary, or tertiary. If it's attached to a primary, you're going to have another carbon or an R group. But what is the rest of the molecule going to be? Hydrogens. How would I draw a secondary? So this one is primary. How would I draw a secondary? 2 R groups. So I have an R group and an R group, and my last one is going to be a hydrogen. How would I do a tertiary? Okay. So that's how we determine if something is primary, secondary, or tertiary. So I'm going to find my alcohol. Here's my alcohol. It is bonded to a carbon. How many R groups? I guess I should have done that. Let me do it in a different color. That way I'm consistent. Here we go. There's a carbon. How many R groups do I have attached to that carbon? 1, 2, because that's a carbon, that's a CH3, right? This is a carbon, CH2. This is a carbon, CH2, right? So how many R groups do I have? 1, 2, 3. So what kind of an alcohol? Tertiary. And you can just put the 3 with the little degree sign too. All right, and B, I'm going to find my alcohol. I'm going to go and see the carbon that that alcohol is attached to. How many, and they call them alkyl groups. How many alkyl groups or R groups do we have attached? 2. So there's a carbon there's a carbon there. So I have 1, 2. Is that the only thing that's attached to this carbon? No, we actually have a hydrogen over here, right? So it always is going to make 4 bonds, but do we have to show hydrogens in skeletal structures? No. Okay, so we'll just erase that. And so this one is a secondary, or you could say the whole word, doesn't matter. Okay. OH. I'm going to find my carbon that it's attached to. How many R groups or alkyl groups are attached? Only 1. So this is A. Okay. Find your alkyl group. Here's my carbon. What's attached to that carbon? 1, 2 groups. What is that? I wrote second primary alcohol. I wanted to write primary. Questions on that? Pretty easy, right? Finally, something easy. All right, here we go. Oh, look, some more functional groups. I wasn't lying. We need to know those functional groups. We need to know them. Identify each of the following compounds as containing an aldehyde or a ketone. How do I know the difference between an aldehyde and a ketone? If I have a ketone, what is common between an aldehyde and a ketone? Doesn't matter. What's common between the two? I have them drawn for you. The what? The carbonyl group. So this is our carbonyl. So the carbon in the carbonyl group is what we're looking at to compare an aldehyde and a ketone. In a ketone, think about a key. You need a lock and a key to make everything work. So how many R groups are you going to have on a ketone? 2. 1, 2. That makes it a ketone. An aldehyde, oh, a poor aldehyde, all alone. So how many groups on an aldehyde? 1. I know these little sayings are funny and kind of ridiculous, but they help. They really do. You'll remember. Okay, so let's find our carbonyl. Whenever we're asked, is it a ketone or an aldehyde, we have to find our carbonyl. So that's what's going to be common between both of them. So now we look at what's attached to that carbon of the carbonyl. So what's attached? 1 or 2 groups? 2. So this is an R group or a C. You could write whatever you want. Either way, R, C, whatever, as long as it's not a hydrogen. Let me make that a C. So what do we have? This is a ketone. Okay, my next one, what am I looking for? Identify your carbonyl. Look at the carbon of the carbonyl. How many R groups or alkyl groups are attached? Be careful with this one. Only 1. Only 1. What's attached on the other side? Why would they do that? Just to mess with you. They did it just to mess with you. So if it's a hydrogen, you don't count it. It's not an alkyl group, right? And so you really only have one thing attached. So what do we call this one? Aldehyde. Because it is all alone. Okay, on the last one, I'm going to find my carbonyl. Look at my carbon. How many different things are attached to that carbon? 2. That ends in a carbon, and that's a carbon. So this is a ketone. Good? All right. I think y'all got this today. Y'all are like rocking and rolling today. It must be because, I know it's not Thursday today, right? It's Thursday Eve. Thursday, it's Friday Eve. Say that right, it's Friday Eve. It's Friday Eve, like Christmas Eve, but it's Friday Eve, the eve of Friday. Okay, classify each of the following monosaccharides by the type of carbonyl group and the number of carbons. So what I want to do is we're going to divide this, right? We have two different things to do. We're going to divide it by the carbonyl group and the number of carbons. And so anytime you're doing this, there are actually 3 parts to this naming system. So first you're going to tell me type of carbonyl, right? What are my choices that we've talked about so far that have carbonyls in them? A ketone, if it's a ketone, what am I going to start my molecule with? Keto, right? If it's an aldehyde, what am I going to start with? Aldo. Okay, then we're going to say how many carbons. So we're going to say number of carbons. So how do I number my carbons? What am I going to say? Instead of saying 1, I would say mono. Instead of saying 2, I would say di. Instead of 3, I would say tri, right? So on, so on, so on. Okay. And then the last thing I have to say is I'm telling you that this is a monosaccharide. This is a sugar. How do we say that in a name? Ose. We're going to end in O-S-E. Glucose, fructose, all of those are sugars. So we're just saying that's a sugar. So isn't it kind of nice to have a map of where you want to go before you start working the problem? All right, so let me move this. I got a little more room. Okay, so first thing I want to do is I want to look at all 3 molecules for step number 1. Then we're going to do step number 2 for all 3 molecules, and then we'll do step number 3 for all 3 molecules, okay? So look at A. Tell me what kind of a carbonyl group do we have? A ketone or an aldehyde? Ketone, because here is my carbonyl, and I'm going to look, and I have 1. And what does this plus sign mean? This is different. It's a chiral carbon. So anytime you get to a point where you have that perfect plus sign, that's telling you that that's a carbon there, but it's not just any old carbon. It is a carbonyl. It's a carbonyl. No, it's not. It's a chiral carbon. So how many chiral carbons do I have on this molecule? I have 1, 2, 3 chiral carbons. How many total carbons do I have? 2, 3, 4, 5, 6. Okay, so make sure you know the difference between a chiral carbon and just numbering the carbons. Okay, so y'all told me, what was this again? A ketone. How about my next one? If I have a carbon, and that's part of the carbonyl group, do I have a ketone or an aldehyde? That one's an aldehyde because H doesn't count. This is an aldehyde. Because the only R group I have is right here. So I only have one R group. How many total carbons do I have? 5 carbons. Okay, how about C? You got to know that that's a carbon right there, where I have that intersection. It's not chiral, but it's still a carbon. So how many groups are attached to that carbon? 2. I have 1 here, and I have 1 here. So do I have a ketone or an aldehyde? Ketone. Now, how many carbons do I have? 3. Does it matter where I start counting them? Like, where's carbon 1? It doesn't matter because it's a symmetric molecule, so it really doesn't matter. But when we draw things in a Fischer diagram, you're always going to start numbering from the top. So we'll just kind of keep that going and go 1, 2, 3. Okay, now let's see if we can put everything together. For A, what are we going to name it? This is a keto, so from the ketone, and then I have 6 carbons, so 6 is hex, and then we need to say that it ends in ose because it's a sugar, so keto hex ose. How would I name B? Aldo, 5 is pent, and then ended in ose. Okay, how about C? It's a ketone, so it's keto, 3 is tri, and then ose. And a lot of times we drop one of the vowels, but it would sound really weird if you dropped either the I or the O. It like wouldn't make sense, and so we keep them both. But I would never grade you on spelling because that would be like the most hypocritical thing I could do, because I do believe I am one of the world's worst spellers. Okay, so now we're going to talk about stereochemistry, not section 63, section 6.3. So stereochemistry is all about that 3 dimensions. You know, what's coming out of the paper at you, what's going in, how things are arranged in 3 dimensions. So when we talk about isomers in sugars, we identify our isomers as L isomers or D isomers. What can you tell me about isomers in general? What are isomers in general? Like, how do I know if 2 molecules are isomers of each other? Well, they have to have the same molecular formula, but they also have to have the same structure, except what? Between the L and D isomer. What's the difference between the L and D isomer? Decide which OH is on. So you look at the OH on the carbon, the chiral carbon, farthest from the carbonyl. All right, okay, now I'm going to look at it. Now what? If it's on the left, if OH is on the left, what is it? It's L. Just remember that. The other one is D. Just remember, L is left. Okay? So these are not isomers of each other. They are 3 different molecules. I'm just wanting to know of each of these molecules, is this the L isomer of that molecule or is this the D isomer of the molecule? So what I need to do is I need to find my carbonyl. Now what carbon has the OH that is farthest away, but is still chiral? The fourth carbon. So I'm looking right here. Is the OH on the left or the right? It's on the right. And so what is this? The D isomer. Okay, do the same thing on the next one. So it's a different molecule. There are different numbers of carbons here. I'm going to find my carbonyl, and I'm going to look. Carbon 3 in this case is the chiral carbon that is farthest away from the carbonyl. Is my OH on the left or on the right? Left. If it's on the left, what kind of an isomer? Y'all are rocking this. Too easy, right? No. All right, so I have my carbonyl. I want to go farthest away. 1, 2, 3, 4, 5, 6, but we still have to be chiral. So we're looking at this one right here, left or right? Right. If it is right, what kind of isomer? The isomer. Questions on that one? Good? Okay. It's the little things that make me happy. All right. Now we have to start drawing these Fischer projections. So when you draw Fischer projections, if we're going to do an enantiomer, what is an enantiomer? If I have one molecule drawn and I want to draw the enantiomer, I want to draw the mirror image, right? So when you do that, the backbone of the molecule is going to be the same. So everything that's not chiral, you can put, before you do anything else, just copy everything that's not chiral. So these two carbons are not chiral. This carbon is not chiral. So go ahead and put that information down. And I know I'm going to have the same number of carbons, so I can still put them. And I know they're going to be chiral. It's just the orientation of the things that are around those chiral carbons is going to be different. So the trick is that anything that's here on the right-hand side is going to be now on the left-hand side. So it's like you put a mirror between the two molecules. You put a mirror right here. Okay? Let me erase that because I don't get too confused. So then anything that was on the left is going to be where? On the right. Now, the only thing you need to be careful about is how you write these, especially for the homeworks, right? So let me do the blues. So if I had hydrogen, let me do it in blue. That way it kind of looks. Hydrogen. Now, can I do this? Or should I do this? Which one's right? The H first. So the H first. Why? Because what you're actually looking at is a carbon bound to an oxygen, bound to a hydrogen. That's what I'm showing you here. But the bottom one, if I had it like that, that would be a carbon bound to a hydrogen, bound to an oxygen. Can a hydrogen do that? No, hydrogen's got one valence electron, so how many bonds can it make? Only one. So this doesn't exist. So if you have that, the homework will mark it wrong, and I would too. And so we're going to put that as HO. Okay. All right, so let's do the other side. Now what do I have to do with the other side? I'm just going to make sure that my oxygen is next to the carbon. So OH, H, H. Okay on that? Yep. All right. Oh, so what do we name this? It doesn't ask you to do this, but you do need to be able to write this. If I give you the name of the original molecule, what's the name of the one I just drew? It's L because our hydroxyl is on the other side, L-fructose. All right, here's another one. So I want to draw everything that's not chiral first. I'm just going to copy it. So now everything that's here is going to go on this side. So I'll put my oxygen next to my carbon, my hydrogen, oxygen next to the carbon. And then everything that is here is going to go over here. So hydrogen, hydroxyl, hydrogen. So doing all these sugars, you know what this always makes me think of? Christmas. Ho, ho, ho. So what will we name this one? What is it? L, sorbitose. Sorbose, not sorbitose, sorbose. Sorry. Good? Okay. All right. Now, there are things when we talk about sugars that are enantiomers, and there are things that are diastereomers. What is an enantiomer? An enantiomer is what we've already done, a mirror image. So what's another way to say that, a mirror image? It's what? So it's that every group on those chiral carbons are flipped, right? So we just flip-flop them. So this is every group on the chiral carbons is flipped, right? So how about a diastereomer? How's a diastereomer different? It's not every single one. So it's one or more groups on the chiral, CHIRAL, carbon are flipped. But not all. Not all. So we're going to compare A, B, and C to D-glucose, and we're going to tell, are they enantiomers or are they diastereomers? So comparing to D-glucose, I'm going to look at each of the groups on the chiral carbon. So here's my first chiral carbon. Compare that on A. Is it the same or is it flipped? So I'm going to compare this one to this one. The same or flipped? Same. Carbon, second chiral carbon, same or flipped? Ooh, this one's flipped. Okay, the third one, same or flipped? Flipped. Fourth one, same or flipped? Same. Is it an enantiomer or a diastereomer? This is a diastereomer. Not all of them were flipped, but at least one was. Okay, the second one, we're going to look again at our first chiral carbon, same or flipped? Flipped. Second one, same or flipped? Flipped. Third one, same or flipped? Flipped. Fourth one, same or flipped? Diastereomer or enantiomer? Enantiomer. Okay. Look at C. We're going to compare that first chiral carbon again. Same or flipped? Same or flipped? Flipped. Second chiral carbon. Same or flipped? Flipped. Third. Same or flipped? same. Fourth, same or flipped. So diastereomer or enantiomer? Diastereomer. So how important is it going to be for y'all to know your vocabulary for this? It's going to be really important because I know that you can do the checking. I know that you have that, but if I say the word or you read the word on an exam, diastereomer, if you don't know what that means, it's going to give you a lot of problems on the exam. So I'm telling you, not only do you need to practice problems, but you also need to work on vocabulary. That's going to help you out a lot. Okay, now, use the structure of D-glucose to answer the following. Draw the Fischer projection of the carbon-3 epimer. What is an epimer? Like, they have all these words that kind of sound similar, right? Epimer, diastereomer, enantiomer. It's a new language. The more you use the language, the better off you're going to be. So what's an epimer? Only one carbon is flipped. Only one chiral carbon is flipped. So how do I know which one? I need to find carbon 3. So where's carbon 3? Here's carbon 3. So what do I do? Draw everything the same except for that one carbon. You know there's going to be a carbon there. Now this one, we're going to flip it. So what's here is going to be here. What's here is going to be here. Now okay on that? All right, now, next one. Draw the Fischer projection of L-glucose. What should we do with that if we're going to draw L-glucose? We need to flip everything. So everything that was on one side is going to be on the other. So let's draw our base again. Okay, so everything that was on this side is now going to be on this side. So I need OH, H, OH, OH. Everything that is here is going to be here. H, OH, H, H. How would my drawing be different if I said draw the Fischer projection of the carbon-3 epimer of L-glucose? What would be different? I would just, for carbon-3, flip that one, right? So I would have another molecule, and this side would be OH, this side would be H, and everything else would be the same. Yeah? So this one, oh, I don't have room to write, but, so this is L-glucose. This is the carbon-3 epimer of D-glucose. Oh, I can't write on that. D-glucose, UCO glucose. And then over here it would be the carbon 3 epimer of L-glucose, right? Okay. Move this back down. Okay, ooh, we're getting to the end. Doing good. Okay. Identify the monosaccharide that fits each of the following descriptions. Unfortunately, what does this mean? We need to do a little memorization. Tongue-tied today. All right, so if you have a monosaccharide, we combine it with glucose and we make the disaccharide lactose. What sugar is that? Galactose. So this one is galactose. It is also called blood sugar. Glucose. You've probably heard your blood glucose levels, right? So it's glucose. And what could I add on here? I could say it's D-galactose, I could say it's D-glucose. Because every sugar in nature is the D form. And the reason for that is that we have enzymes inside of our bodies that are so specific, they can tell the difference between a D isomer and an L isomer. And they don't work on the L isomers. So if you ate food that only had L-glucose in it, no D-glucose, you would not get anything to actually eat, right? You would basically starve. So anytime you see glucose written, what can you assume? It's in the D form. It's in the D form. So I'm not sure how picky your homework is about that. I know if they say, okay, is this the D isomer or the L isomer, you have to put it. But it should accept with or without the D, but I'm going to suggest you write it without the D. And you'll probably have less issues that way. So if it's not written, it's assumed as D. Okay? What? If it asks you to write the D, write the D. Oh, it does. It made you write it. Okay. Okay. Good. Well, that's good to know. Because sometimes it's hard for me to know what it's going to accept from y'all and what it's not. All right. Also called levulose. Fructose. U-I-T. Told y'all I couldn't spell. All right. So now we're going to talk about diabetes. What happens in someone who has diabetes? There are two different ways that you can have diabetes. You can have type 1 and you can have type 2. Before we answer questions about it, let's talk about what the difference between type 1 and type 2. In type 1, the body does not make or does not make good insulin. Sometimes it'll make insulin, but it's not quite right. But there's something wrong with the insulin. That's type 1. In type 2, your body makes the insulin, but your cells don't recognize it, right? So what's the point of insulin? I was so excited we had a crawfish boil and I ate crawfish. What happens, right? I had some potatoes in that boil, right? We had some carbs in there. What happens to my blood sugar? My blood sugar goes up. Well, that's great that I've got sugar inside of my blood. But is it going to do me any good inside of my blood? No. Where does it need to go? My cells need it for energy. So there has to be some kind of chemical signal that tells all the cells in my body, hey, there's sugar in the blood, you need to take it out and you can use it for energy. That's what insulin does for you. So your body starts to make the hormone insulin at this point. Your body makes insulin. So if your body makes insulin and it tells those cells, hey, you can pick up the sugar, it's floating around out there, right? What's going to happen to your blood sugar levels? They're going to, guess what? They're going to drop. They're going to go down. All right, now, what's going to happen? It goes down, your cells take up the glucose, your blood sugar drops. You know, you've been in chemistry class for the last 3 hours. What do you feel like? You're hungry, right? So what are you going to do? You're going to go across the street, right? No, not across the street. We're in the Union. You're going to go get something to eat in the cafeteria, right? What's going to happen to your blood sugar? It's going to go up. You're going to make insulin again. Your cells are going to take up the glucose, and your blood sugar is going to go down again. Now, let's say this is at night, and you go to sleep, and you get to sleep for like 8 hours, and it's amazing. I haven't slept in 8 hours, for 8 hours, in way too long. So what's going to happen? You sleep for 8 hours. You haven't eaten in 8 hours. Is your blood sugar just going to completely plummet? No, why not? My body's going to make a hormone that's called glycogen. Well, not glycogen, glucagon. 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 I'm going to make glucagon. Glucagon tells my liver to metabolize some of the sugars that are inside of the liver to increase my blood sugar levels. So I haven't eaten anything because it's night, but my blood sugar goes up. And my body makes, guess what? Insulin, and the blood sugar drops again. So you'll have a similar pattern whether you're asleep or awake because of the insulin and glucagon cycle. Okay? All right. So let's answer our questions. Most cases begin in youth. Is this type 1, you think, or type 2? Type 1, because if your body doesn't make insulin, it's a genetic thing. It's never going to make insulin. So we're going to see that in patients who are really, really young. B, insulin is often present, but glucose not transported into the cells. Type 2, you've made the insulin. It's just not telling, the cells aren't responding to it. Can be managed with diet and exercise. Type 2. Now, that does not mean that it's not important to manage diet and exercise if you are a type 1 diabetic. It is super important for you to manage diet and exercise. But what we're saying is that if you have type 2, you can not exhibit the symptoms of diabetes if you can manage it with diet and exercise. Does that make sense? Because a lot of times that gets confusing. All right, so part 2 of chapter 6 on Tuesday, part 3 of chapter 6 on Thursday. Good to go? If you have any questions, please feel free to contact me and set up those Zooms or send me emails. Good to go. You're free at last. You can go increase your blood sugar levels. Okay, anybody on Zoom need anything? Before I'm looking at the chat. No, I'm happy to answer anything y'all have. All right, if y'all need anything, send me an email, set up a Zoom. I'm happy to help. I'm going to go ahead and end the Zoom. Y'all have a great day.